Welcome back to the shop and to the channel. We are back to work on this seemingly never-ending quest to build a new drive shaft for the K&T Universal Milling Head. I want to finish machining this test piece as if it were the whole length of the original drive shaft. Now I know there's some that think I should just jump in and made the real part from the beginning, but I'm still learning at this, and I kind of want to make sure that I've got all my ducks in a row before I go ahead and use all the material. I only have enough really left over to make the full-size shaft. And just like when I take my Jeep off-road, you know, it's about the journey. It's not always about the destination. Well, the first thing I want to do is go ahead and shorten this piece of material. There's a good chunk here that doesn't need to be on the end. I can take probably 3 inches off of it. So we got it over here in the good old Harbor Freight horizontal bandsaw, and we'll get it cut down to a reasonable length. Now, say what you want about that Harbor Freight bandsaw, but it does make some really nice cuts. It doesn't take a whole lot of tuning once you get it set up, and I can cut 1/16 inch slivers off the end of a piece of square tube all day. So what I need to accomplish here is to machine down the end of this to match what's on the original. There's a boss here on the end that takes a bearing, and the inner race on that bearing is 20 millimeters. So that equates to about 787 thousandths of an inch, 787 and 5/10. So that'll be my target size here. I want it to be a nice snug interference fit. Well, now that I got the 4-jaw chuck ready for this lathe, we'll go ahead and put it to use. I wanted to use this lathe because the spindle bore is larger than the 1¼ inch diameter of the drive shaft. And I'm going to seat this down into the spindle here so I won't have a whole lot of stick out. This will become even more necessary when I finally machine the full size shaft. I'm going to get this part snugged up in the chuck first. I'm not going to tighten down too much because I don't want to do any damage to the shaft. And then I'll insert these copper shims that I made out of just some 1/2 inch copper pipe. I just flattened it in a vise, and I'll put one under each of the jaws to protect the surface of the shaft. And because this copper is softer, it actually makes it a little bit easier to dial this in, because they'll slide on the material better than the hardened surface of the jaw. I'll bring over my dial indicator here and get it set up on the end of the shaft, and now you might see why I left the shaft as long as I did, even though I'll be taking probably about half of what's past that groove off. I wanted to have a nice untouched section of the shaft that I can indicate on and get this running true. I think that's looking pretty good. That's easily within a half a thousandth, maybe even less. Now that we have this running true, I want to go ahead and turn the diameter down on this end piece until I've turned away all of the grooves that I made when machining the splines. Well, I think we can speed this lathe up a little bit, so I'll go ahead and switch the belt over to the next pulley and try to take off a little bit more material a little bit more efficiently. For those of you that watched the video of machining the backplate for this chuck, you'll note that when the cutter comes in contact with the material, the motor does seem to get bogged down a little bit. But what I also find interesting is it's not bogging down as much on the 1045 at this diameter as it did on the cast iron at the 6-inch diameter. Now, I know a lot of it has to do with the torque in the moment arm at those different diameters, but I still find it a little bit frustrating that I am still getting that motor bogging down at 15,000 depth of cuts, which the other lathe, which is running on a 110 volt motor, has absolutely no problem doing. I've read through most of the comments on that last video, and I've tried to reply to all of them. I don't always get a chance to reply to every comment, but I certainly give it some effort. And there were a lot of folks that offered some possibilities and even some things to check. And I'm fairly certain it has nothing to do with the wiring, at least up until it gets into the pecker head. I'm running a 10 horsepower American rotary phase converter. This happens to be the only thing that's running off of it at the moment, and I'm using decent gauge wire all the way up into the motor. The motor wiring is wired as if it was correctly wired for low voltage 3-phase, so I don't see it being anything up until that point. Now, some of the comments were in regards to whether it was wired for high voltage or low voltage. And even though the wiring looks like it's correctly done for low voltage, I leave open the possibility that it could be wired wrong. And the only reason why I say that is when I picked up the lathe, the previous owner made claim that it was wired for 480 volts. But like I said, I opened up the pecker head immediately and looked, and it is wired for 220 low voltage. So unless somebody has modified the internal windings of the motor, I don't see how this thing could possibly be wired for high voltage. But regardless, in any case, this motor is going to end up coming out of this lathe for either some reconditioning or replacement. But I won't be doing that until I actually complete the full-sized drive shaft for the K&T Universal Head, which, if everything goes according to plan, will actually be the next thing that I work on. So the last few videos of me making these test pieces out of Delrin and out of this piece of 1045, I get to do that all over again by making the actual drive shaft. And this time, hopefully I can take advantage of any of the mistakes or adjustments I made during these last experiments, and I won't be making them when I make the final part. Well, now that I have this end piece all smooth up into the groove, I'm going to take a quick measurement here. I think I'm probably over an inch, and yeah, it looks like I'm about 10 thousandths over an inch yet. So that means I have, what, 33 thousandths plus or minus to take off yet. Well, before I continue turning the diameter down here, I think I'm going to change gears just a little bit. I've got the parting tool on the tool post, and I want to clean up this raised end of this drive shaft. It should be about 200 thousandths of an inch in thickness. So I've got the parting tool here. I've got a dial indicator on the bedway. We'll go ahead and zero this out. We'll move over 200 thousandths and we'll clean up the face of that end piece. I don't know what you want to call it. Spot on the other side of the groove. Well, with that face cleaned up, I'll reset the dial to 0 and then move the carriage about 580 thousandths, and that's where I'm going to part this off. With the lathe running in back gear, we'll engage the cross-slide power feed and part this piece off. Oh, well, that's pretty unfortunate, but I have the feeling I know exactly what happened. I never checked the tool post to see that it was perpendicular to the spindle before I started this. Oh, well, I guess I'll have to try something different. Oh, that's nasty. Well, I don't have another carbide insert for that parting tool, and I can't really tell if there's been any damage to it, so I guess we'll just go old school and use the hacksaw to finish this off. Well, with that piece cut off, I'll go ahead and clean up the end here, and we can get to finishing the machining of the diameter of this boss for the bearing. Seriously? Again? Well, I've got a fresh insert in the tool holder, so now I can finally finish off the end of this boss. I'll take a quick measurement here to see where we're at and how much more I have to remove. Well, it looks like we got about 824 thousandths plus or minus, so about 37 thousandths more to come off of the diameter. I am going to swap out this insert, however, for one that's got a sharper cutting edge on it and should give me a real nice finish for these last 37 thousandths to come off the diameter. Well, before I go breaking more inserts here, I'm going to go ahead and adjust the height of this tool so it's properly on the center line of the spindle. Well, being that it's a new tool, I want to go ahead and touch off, and we'll take 10 thousandths off or so, and then we'll take a measurement to see how far we have to go. Slowed down the feed rate a little bit here too to try to get that much more of a better surface finish. I really like these inserts. They do give a really nice finish, but just like anything else, you have to have the feed set just right. Take another measurement here to see how we're doing, and it looks like we have about 18 thousandths yet to go. Taking 10 thousandths off on this next pass, which should leave us about 8 thousandths to go. We'll go about halfway again, about 5 thousandths this time. Dial in the remainder that needs to come off the diameter, and we'll go ahead and take this pass and take another measurement to see how close we are. We should be spot on, hopefully not under, but maybe a little over. So it looks like I'm still about 1/1000th of an inch shy of my final dimension. So I'm going to try to dial in half of that. We'll see if we can dial in just a tick on the dial and see if we can't get a little bit closer. I'm going to use a little blue Sharpie on the end here, and the idea being I'll touch off with this tool just till the blue starts to go away. That should get me really close to where I want to be without taking off too much. And I think that hit it just right. Looks like we're at 787 and 5/10, which is exactly what I was going for. Well, before I call this done, we'll put the chamfer tool in here and just break that sharp edge, and then maybe use a little bit of Scotch-Brite to give a little bit more polish to that boss. Well, I think we can call this part finished, so we'll remove it from the chuck and take it over to the bench and have a look. Well, I think that finally wraps up this test piece. I think this is really close to what I suspect the original looked like, just shorter. I learned a lot in making this, and I think I did pretty good in getting this bearing boss right on size. And I'm happy with the splines and how they came out. The gear that mates with this mates up with it perfectly. I think this is going to do well as long as I can make the real piece as good as I made the short piece. Well, barring any interruptions, I should be able to take this last piece of stock here and cut it down and make a new drive shaft. That should be the next video that comes out on the channel. I've been having a lot of fun working on these parts, and even though I might have damaged this tool holder, I think it's recoverable. I'll have to take a file to it and see if I can't clean this up a bit. I've got some other inserts on the way, so hopefully I'll be able to salvage this. As always, if you like the video, give it a thumbs up and let me know what you think down in the comments. If you're not a subscriber, I'd appreciate it if you would subscribe. It doesn't cost you anything to do so, and you'll get notified if you click that bell icon when I upload another video. And a special shout out to those who've supported the channel through PayPal donations or through Patreon. It really does make a big difference having that support. Well, that's it for now. Thanks for watching, and we'll see you on the next one.